Hello and welcome again. It's 1.8, the final section in Chapter 1 that we're going to be working through today. After this, we'll have a couple of days of review. We'll do a little practice test, make sure we are caught up on the ideas and the concepts from this chapter, and we'll probably have a test like next Monday or something like that. Your very first test. I know you're all so excited. Your very first test. It's a big moment of your freshman year. So here we go. Right. This is 1.8. We're going to represent functions as graphs. In the previous section, 1.7, we represented functions as verbal rules, as equations, and as tables. And so now we're going to add that last one. We're going to represent it as a graph. You can see the learning target here says you will represent a function as a graph, which is kind of exactly what I said right there. So I know that that's redundant, but seriously, that's what we're doing today. Like that's what you should learn today is how to represent a function as a graph. So yeah, there you go. Let's move on to the next little bit here. So remember these things when we are representing functions as a verbal rule. We might say something like the input is doubled plus 1. Let's just add the plus 1 there for fun, right? The input is doubled plus 1. And so that would be a verbal rule describing it. A table that represents that might be something like this, where we have a few values here. Double the input, 0 plus 1, 1. Double the input, 2 plus 1, 3. Double the input, 4 plus 1, 5. Double the input, 6 plus 1, 7. Double the input, 8 plus 1, 9. So there's a table that represents that verbal rule. We doubled the input, right? Notice that double 0 is 0, and we added 1, so that's where that 1 comes from. We can make an equation for that. Let's do equation in a different color. We'll do equations in blue. We need to double my input. So there's 2x, right? Double my input. And then I'm going to plus 1. I'm going to add 1 plus 1. And so that's what my output equals. Double the input plus 1 equals my output. Now, finally, the last thing that we're going to do here today is to represent this as a graph. And you might recall that a graph looks something like that. It has an x-axis and a y-axis, and that there are points along each of those axes, something like that. Y-axis, x-axis, there's points all along here. These points are represented by the numbers along the graph. That's a 3, not a backwards C. And so that point right there is the point 1, 1. And this point right here is the point 4, 3. Remembering, of course, that a point is an x-coordinate, then a y-coordinate, and we call this thing an ordered pair. Ordered because the order does matter. The first one is always the x, and the second one is always the y. So we can represent graphs in that same sense. And if I was smart, what I would have done is made a graph of this particular function. Let's do that really quickly, because so I'm not an idiot. So let's do that. And we'll do this in, let's do it in purple. So we go to the point 0, 1, 0, 1. There's a point right there, and then I go to the point 1, 3, 1, 3. There's a point right there, and then I go to the point 3, 7, 3, 7. That's like up here. It's a little bit taller, a little bit too tall. This graph here, and then the point 4, 9, which is like way up here, right there. So there's a graph that represents this particular function that we have thus far. All right. Okay. Next slide. So let's do some examples. We're going to graph the function y equals 1/2 x with the domain 02457. You guys can hear that's my son in the background. It's the weekend and I brought my kids to. They're the audience today for my video. They're obviously enthralled. That's why they're not making any noise. They're definitely not asleep. I haven't put them to sleep. They're just so enraptured with my voice that yeah. They might also be watching Minecraft videos on the computer. So that's all the good thing that they might be doing. But I think it's the map. It's probably the map. What were we talking about? Oh, right. So domain. So notice that this says with the domain 02457. That means that we are going to use just those values in the domain. So the first thing that I want to do is just to make a table. Making a table allows me to easily see the ordered pairs because when I plug in 0, I know that I can plug in 0 to the function and I can and then I can find what my output will be. So this is going to be 1/2 times 2, and then this one will be 1/2 times 4, and then this one will be 1/2 times 5, and then this last one will be 1/2 times 7. So this 1/2 times 0, that's 0. Then 1/2 times 2. Remember when we're multiplying fractions, a whole number is like over 1 and you can kind of cancel the sides, right? So that's going to be 1. That cancels to 1 and that cancels to 2. And so that's 2. This one can't cancel anything. 1 times 5, 2 times 1, that's 5 halves. And it's same with this one, right? That's 1 times 7, 2 times 1, that's 7 halves. So there's my set of ordered pairs that is going to go with this particular function. We have 0, 0, and we have 2, 1, and we have 4, 2, and 5 halves, and 7 halves. And we shouldn't be afraid that those are fractions, because fractions aren't scary. Fractions are your friends. And so we're just going to plot them where they belong on the graph. So let's make the graph over here. We're just going to do a top quadrant graph. So we're just going to look at that section up there. So this is going to be 1, 2, 3, 4, 5, 6, 7. And notice the care that I am taking to both label and mark my graph, right? I don't want just 2 lines. Math is about communication, so we communicate well. All right, so there's my graph. Let's use what's one that's going to stand out real well? Let's use red. Actually, let's use green because that's what we did the points here. So we're going to go to 0, 0. We're going to plot that point 0, 0, and then we're going to go to 2, 1, x2, y1, and then we're going to go to 4, 2, 4, 2, and then we're going to go to 5 halves. Well, 5 halves as a fraction might be kind of hard to read. Where do I put it over here? It might be beneficial in this case to look at it as a decimal. 5 halves is 2.5 as a decimal, and then let's just say it since we're here. 7 halves is 3.5. So when we go over to do 5, 2.5, we're going to go halfway in between the 2 and the 3. What happened? Cut that out. Halfway in between the 2 and the 3. And the same thing for 7 halves. 7 halves is 3.5, so we're going to go halfway between the 3 and the 4 to make that last piece. And that's it. We've graphed the function. We made a table. We plugged in those particular values in the domain to find the range, which gave us the set of ordered pairs, which we then graphed on a graph. Graph the function. The table shows the average score, S, so that's one of my variables, on the mathematics section of the Scholastic Aptitude Test, that's a fancy name for the SAT, in the United States from 1997 to 2003 as a function of time, T, in years. Hi, Wesley. Is there any food in the food room? We'll just have to check in a little bit. I'm going to finish this video with. Wesley wanted some food. Sorry, Wesley's 5. He wants food every 10 minutes. So that's just going to happen when I link the video. Anyway, what were we saying? Time t in the year is 1997. In this particular table, the way it's set up, 0 corresponds to the year 1997. So this is 1997. 1 is 1998, and so on. 99, 2000, 2001, 2002, 2003. By the way, that's my graduating class right there. Okay, so let's make a graph. So we need to go from 0 to 6. 1, 2, 3, 4, 5, 6. This, by the way, down here is the S-axis. Notice because they don't have any X's or Y's, I'm using S. And no, I'm wrong. This is the T-axis. Let's try that again, because this is time. This is the T-axis, because that's not an S. That's a T. Because that's time. Hey, and my scores are the S-axis, so that's this one up here. This is the S-axis. And notice that the X-axis starts and it goes up in the 500s. Now, I don't want to count from 0 to 500 on here because that would be silly. So what I'm going to do instead is I'm going to draw a little squiggly right there, because the squiggly means, hey, this isn't starting at 0. And then we're going to start, I think we should just start at 510 maybe, right? So call that 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And I don't know if I want to label all of these. I'm going to label a few so we get the idea. And then this one up here is 520. Okay, and then let's just do our points. So 1, 5, 12. 1, 5, 12 is right there. 1, 2, 3, 4, 5, 6. And then we'll go back and do 0, 5, 11. 2, 5, 11. Try that again. Maybe, there we go. 3 is 5, 14. So we were clearly, my graduating class was clearly significantly better than the rest of the earlier ones. 4 was also 5, 14. My wife's graduating class, equal to mine. And then 5 is 5, 16. We'll just ignore them because they clearly weren't that much better than us. And then 6, 5, 19 is right there. We have graphed the function. Last thing we're going to do here, write a function rule for the given graph. So I'm going to draw a graph. And then, now they want more popcorn. I don't have any more popcorn, dude. Sorry. It was in my desk, but then I ate it. Well, more accurately, you ate it. So, okay, so here's our graph. 1, 2. Is it entertaining listening to my children ask me for food while I'm trying to do this? I'm going to do the 1 point there. 3, 4, 4, 5, 5, 6. There's our graph. And we want to write a function rule for this. So let's go through and just make a couple of different representations. We'll start with a table. And the table is just going to be the ordered pairs that we saw over here. So this particular one right there is 0, 1. Because now my kids are going through my desk looking for more popcorn. There's no more popcorn. So that first one was 0, 1 because the x was 0 and the y was 1. This next one is 1, 2 because the x is 1 and the y is 2. This one after that is 2, 3. And then we have 3, 4. And then we have 4, 5. And then we have 5, 6. So there's a table, but that's not a function rule. Let's write this as an equation next. Okay, wait till I'm done. I'm almost done. So what is happening over here, right? What is the verbal rule that we're doing? Because that might help us make the equation. Verbally, what's happening? The output is one more than the input? Is that what's happening every single time? The output is one more than the input? Yeah, that's what it looks like. The output is one more than the input. So how can I write that as an equation? If my output is y, and I need to state that the output is one more than the input, my input is x, and the output is one more than that. So it's x plus 1. So there's a whole thing. There's the graph, there's the table, there's the equation, there's the verbal rule. And that's it. I'm going to go feed my children because apparently they're going to die if they don't get food in the next, 30 seconds. So, you guys enjoy. There's going to be something up on Google Classroom for you to do right after